Hello, my name is Shehryar, and this is my Physics 2212 Lab 6 Magnetic Molasses. Today we'll go over Introduction, Models, Experiment Code, Discussion, and Conclusion. The purpose of this lab is to experiment with a ball of magnet falling through a tube of aluminum foil to see how its speed drops, and to simulate opposing magnetic fields caused by induced current in a tube of aluminum foil to a ball magnet and measuring its effect on falling speed of the magnet. The fundamental physics principles we will be using is Biot-Savart's law, where the magnetic field of constant current is based on the direction of current, length of wire, and distance, and this would be used to find the magnetic field of a dipole. Faraday's laws and Lenz's law, where an induced EMF will be produced by the negative change in the magnetic flux over time. Lenz's law states that nature abhors a change in flux, causing for the negative sign in Faraday's equation. These would be used to find the opposing magnetic field by the induced current, and Newton's second and third law, where F is equal to ma, and each force has an equal and opposite reaction, and this would be used to find the force on the magnet via the force on the tube. The models we will be using is the Biot-Savart's dipole general form, Faraday's law, and the changing magnetic flux of the magnet falling down the tube on a singular ring. We will also be using the force on the loop, Newton's second and third law, and the velocity and position update. For results preview, you can see on the left an image of the magnet falling through the tube, with the red being the north pole and the blue being the south pole, and a velocity versus time graph on the right. Some assumptions we have is that there is negligible air resistance, the ball magnet acts as a magnetic dipole for Biot-Savart's law, and the only forces included are the magnetic and gravitational. For materials, we have the magnet as part of the system, the tube of aluminum foil as surroundings, and earth as surroundings. For our experiment, we first wrap a tube with aluminum foil, then we drop a magnet through it, measuring the time it takes to fall, and lastly we repeat it 5 times and find the average time. For data collection, on the left you can see a video of one of our experiments, and on the right you can see our base time and the average time it took to fall, with the average time being slightly longer than the base time without a tube. For code setup, we have mu naught, the resistivity of the aluminum foil, gravity, mass, the magnitude of mu of the magnet from our previous lab, as long as some of the geometries of the tube. Continuing our code, we have the dipole equation for the magnetic dipole, as well as the d flux dt calculation using the equations in our models from earlier. Within our loop, we use the previously defined functions to solve for the forces in the ring for each ring in the tube, as well as updating our position based off those forces in combination with gravity. For results, on the left you can see the magnet falling through the tube, and on the velocity versus time graph, the moment after the magnet enters the tube, its speed decreases, which shows that there is an opposing force on the magnet caused by the induced current in the tube, and then as soon as it exits, it starts to speed up again. And then bottom, we can see the estimated time of 0.79 seconds. For discussion, some similarities is traveling through the aluminum foil is slower than if you weren't, and some differences in the experiment, it only took 40.43 seconds, whereas the code took 0.79, and the simulation has ideal circumstances, which completely ignores air resistance, whereas the experiment can't. And for possible sources of error, it's not perfectly vertical falling in the experiment, and physical interaction with the tube messing up with the falling speed. For discussion questions, if the resistivity of the conductor was reduced as close to zero, a very small resistivity would mean a much larger current induced and force, making the magnet fall much slower. And if there were holes or slots cut into the tube, this would reduce the current in the tube and the force on the magnet, allowing for the magnet to fall faster. In conclusion, we experimented on the magnet falling through an aluminum tube. Have a good day and have a good summer.